Hello, 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 and welcome. Happy New Year, happy 2021. We're back. I hope you had a very restful and healthy and safe 2 weeks off for winter break. We are here. It is pouring rain outside. It is very cold in the classroom because the heat is not working. But nonetheless, we will persevere through this adversity and work on some math as we enter a new unit where we're looking at multiplying and dividing later fractions. We're going to start with multiplying. And for this first day, we're going to start with a little bit of review. It may be 2021, but we're going to throw it all the way back to something that we started learning in 2019. Can anybody remember 2019? It feels like 6,000 years ago, and it also feels like 3 days ago at the same time. I don't understand how time works. That's Stephen Hawking's job, not mine. So today we are going to be reviewing the area model of multiplication. I can already hear the groans from the standard algorithm fuddy-duds in my class. Well, deal with it. We're doing area model today. Thanks. Here's what you're going to need. Something to write on, something to write with. Graph paper and a ruler. I left it up there. Some people really like having very neat and orderly area models. So if you want to do it on graph paper and practice it on graph paper today, I'd recommend it. And then down here are our I cans. I can use an area model to solve a multi-digit multiplication unknown, and I can define partial product. So just as a reminder, when we're talking about the area model of multiplication, we're really bringing it back to this idea and this concept of finding the area, or the amount of space inside of a rectangle. Because the way you can calculate the area inside a rectangle in square units is to multiply the length by the width. So we can use a rectangle to solve any multiplication unknown with two factors. If you're worrying about multiple factors, then you'll need multiple area models. That's not today's lesson. Okay, and we have a three-step process for finding the product using an area model. And the first step is to take our factors and put them into expanded form. This is going to let you know how many partial products you're going to need and really what you're going to need to divide your area, your rectangle into, okay? Because thinking about this idea of partial products, or finding products with a smaller multiplication expression inside of a larger multiplication expression, and then adding those together at the end, this idea of if we had something that's 5 by 4, let's say. This won't necessarily work for area model because it's only 1 digit by 1 digit, and we kind of have 5 by 4 memorized or almost automatic at this point. But if you were to divide this up, let's say I took this 5, length of 5, maybe 5 inches, 5 feet, 5 miles, 5 of anything, and I divided it up into 3 plus 2, let's say. All I've done is I've gone, okay, I'm going to break this one large rectangle up into 2 smaller rectangles. Have I made this rectangle any larger or smaller by itself? No. All I did was I broke it up into 2 smaller pieces. Okay? So now when I do 3 times 4 and 2 times 4, I get partial products of 12 and 8. Then when I add those partial products together, 12 plus 8, I get 20, which is equivalent to 5 times 4. So by breaking up our area into smaller rectangles and finding partial products, we make a larger equation, a larger multiplication unknown, a lot more manageable. So let's go ahead and watch. So this is the I do portion of the program, where we're going to use these 3 steps to find a larger multiplication unknown. So let's try 38 times 27, let's say. Okay? And the first thing we're going to do right there, expanded form. So taking this 38 and going, well, let's look at each place and really expand out what each place, what the value of each place is. So our 38 here is really equivalent to 30 plus 8. We have our 3 tens, or 30. We have our 8 ones, okay, times 20 plus 7 is the expanded form of 27. So taking each place of our two terms, of our two factors, and writing them out kind of more fully so we can see what the value of each place is a little bit more clearly. And we're going to use that in our rectangle. So let's say the length of our rectangle is going to be 38. We'll put our 38 up here. We'll put our 27 here. This lets me know what my partial products are going to come from and what I'm going to divide my area into. So I'm going to make a line here to divide it into two smaller lengths, 30 plus 8. Is that feeling familiar? Now I'm going to take my 27, thinking this line segment is a length of 27. I'm going to divide that into 20 plus 7. Okay, so all we're imagining here, length and height, 30 plus 8 and 20 plus 7. And what this does is this gives us 1, 2, 3, 4 partial products to find. We have 30 times 20, imagining this rectangle having a length of 30 and a height of 20. We have 30, right? This is still 30 times 7. We have 8 times 20. And we have 8 times 7. Okay, now step 2, multiply to get your partial products. So we have 30 times 20. I'm going to use my zeros shortcut here. I see there's 2 zeros. And then we have a 3 times 2, right? 3 times 2 is 6, times 10, times 10 to get 600. 30 times 7, or I can think about it, 3 times 7 times 10. 3 times 7 is 21, and then multiply by 10 by adding that 0, scooting everything over one place. Okay? 8 times 20, or 8 times 2, which is 16, times 10. And then 8 times 7. I don't have this one memorized, so I'm going to look at my multiplication chart over here. That's 56 is 8 times 7. Now, step 3, add your partial products together. So we're going to have 600 plus 210 plus 160 plus 56. Okay. 6, 1 plus 6 plus 5. Well, 5 plus 1 is 6. 6 times 2 is 12. Regroup 1. And then 6, 7, 8, 9, 10. So I end up with a final product of 1,026 for our initial problem of 38 times 27. Okay. For the standard algorithm fuddy-dudds, most of you figured out last year that area model and standard algorithm aren't that different. It's the same steps. You're finding the same partial products. You're just doing it in a little bit of a different way. An area model can be a lot clearer for some people to see. Okay? Let's go ahead and move to our digital whiteboard, and we're going to practice a few. Starting with 36 times 8. So thinking about first step of draw your rectangle. Okay. And let's set up our problem. We're going to put 8 on one side, and we're going to put 36 on top. Okay, so first step, expanded form. The 8 is kind of already in expanded form because it's only one digit. It's only got a ones place. But our 36, we can split up, right? Our 3 tens and our 6 ones into 30 plus 6. Hello. That's new. We've got some like new features going on in the old thing here. The old whiteboard here. Oh, hold on. I didn't want to do that. There we go. Okay. So now our partial products look like 30 times 8 and 6 times 8. Oh my goodness, what is happening here? There we go. The box has a mind of its own. So we have 30 times 8 and 6 times 8. Go ahead and find those partial products and add them up and see what you come up with. Feel free to use our multiples of 10 shortcut here for 30 times 8. You can really think of it as 3 times 8 and then add a 0 at the end to multiply it by 10 because it's 3 tens times 8. So we can say 3 times 8 is 24 and then put a 0 at the end, slide everything one place over to the left to multiply it by 10. Okay, and then 6 times 8, consult your multiplication table. If you don't have that one automatic, that's not a problem. That is 48. Okay, then go ahead and add those two partial products together to get your total product. And you can go ahead and put the answer in the chat once you have it. Those standard algorithm fuddy-duds in there. Make sure you're trying it with area model. You can use standard algorithm to check your work once you are done with the area model. Okay. Go ahead and line up your 240 plus 48. It's turning all my zeros into just more snapped together circles, which I think is interesting. I liked it for the rectangle. I'm not so sure about for the zeros there. 0 plus 8 is 8. 4 tens plus 4 tens is 8 tens. And then 2 hundreds plus 0 hundreds is still 2 hundreds. With a final result, will it just wipe everything out if I circle it, of 288. No, didn't do it that time. Probably because there's something in the middle. Check your work, make sure I'm right. See some 288s, see a 248 in the chat. Nice work. Make sure you've got all the pieces in there. Make sure you didn't do the 4 plus 4 equals 4 thing. That can happen from time to time if we're working quickly or just, you know, it happens. All right, let's try one more. Well, we'll try 2 more. Let's do a 3 by 1 here. So 484 times 5. Go ahead and draw your rectangle and think about how many pieces are we going to separate our 484 length into. We're going to use 5 on the side here. But what would be the expanded form of 484? Yeah, because it's got 3 digits, we're going to need 3 pieces here. We have 400 plus 80 plus 4. And each one of these is going to get multiplied by 5. So go ahead and give that a try. I'll give you a little bit of time to work on your own before we do it together. So put in your partial products in each one of the boxes and then add them up once you've calculated each partial product. Okay, so we've got 400 times 5. This box is killing me. 80 times 5. It likes to expand itself. And then 4 times 5. Go ahead and calculate each one of those. And then add up all of your partial products to find your total product. Okay, 4 times 5, 20. 80 times 5, or 8 times 5 is 40. And then multiply by 10, because that's 8 tens times 5. Okay, those can be tricky because you've got your 8 times 5 ends in a 0 already. But don't let that throw you and go, oh, well, I must be done. Because think about reasonableness there. Can 80 times anything greater than 1 equal 40? No, right? 80 times 5/10 or 1/2 actually equals 40. And then 400 times 5, or 4 times 5, equals 20. And then we're going to do 1 and 2 zeros. Because we've got 400s times 5. And when we multiply by 100, we can move everything 2 places to the left, or in essence, add 2 zeros at the end. And then we're going to add them up. Okay, looks like Lily's got an answer in the chat. Gia's got an answer in the chat. Go ahead and check, make sure, does your answer match theirs? Or do you have a question or a wondering? Let's go ahead and add it up. We have 2,000 plus 400 plus 20. And the nice thing about this one is it's just a bunch of zeros all the way down, except for our one number in each row. It's nice and orderly there. Look at that. For a final total product of 2,420. Can't quite see it on the, let me scoot this over a little bit. There you go. Now we should be able to see it. 2,420 as our total product. Okay. Last one's going to be a 2 by 2 because these can be the trickiest because there's a bunch of different moving parts in here. So we've got 73 times 49. I'm going to erase this bit from the last problem just to declutter things here. Really? Hold on. Let me get rid of this. Get out of here. There we go. Okay. 73 times 49. Now these can be tricky because, why? Because we're going to have to use expanded form on both of our factors, our 73 and our 49. So it's going to look like the example we did behind me there. So here's our rectangle. Okay. And because we're dividing both of them, will this do it? It will. Great. Can I move this down, I wonder? No. Oh, it like adds or subtracts a column. That's fun. Okay. I'll remember that for next time. So we're going to put 49 on top. We end up with 40 plus 9 and 70 plus 3. Now, obviously, this is not to scale, meaning if we look here, these are 4 evenly shaped squares, right? Which doesn't really make sense if we have a length of 70 plus a length of 3. But important to remember that we're really just using this as a multiplication tool. Okay, if it was to scale, you'd have a big, long height of 70 and a little itty bitty bit of 3. But because we want space to do all 4 of our partial products, we're not having to match the scale that they would actually be if we had a 73 by 49 unit rectangle, if that makes sense. And then go ahead and put in all your partial products here. So we've got 70 times 40. We've got 70 times 9. We've got 40 times 3. Oh my gosh. And we've got 9 times 3. Hold on. This is a mess here. There we go. I'm going to move these as well. There we go. Let's put these back where they belong. 40, 9, 73. Okay. And I have seen from some mathematicians, as I move myself to the other corner here so you can see everything that's going on, I have seen from some mathematicians a really good strategy of actually going ahead and putting the 70 and the 3 over here and the 40 and the 9 below, just to remind yourself what those lengths are. That helps see a little bit more what those all those partial products are. So if that helps you, I'd highly recommend doing it, of taking your length from the top and also putting it on the bottom, taking your height from the side and also putting it on the other side. So I think that can help more clearly see what those lengths are and what partial products you need to find. All right. So now let's find our partial products here. 70 times 40. We can use our shortcut here. So use 7 times 4 is 28. And then adding 1 and 2 zeros, because there are 2 zeros that we took out to multiply by 10 and then multiply by 10 again. 70 times 9, or 7 times 9 being 63 times 10. 40 times 3, as this continues to move, or 4 times 3 times 10. And then 9 times 3 is 27. Okay, go ahead and add those partial products together to see what you come up with. We've got one answer in the chat. Let's see if we can get a couple more here. 0, 0, 0, and 7 makes 7. 3 plus 2 is 5, plus 2 more is also 7. 8 plus 6 is 14, plus 1 is 15. So we're going to regroup our 1,000, and then 1,000 plus 2,000 is 3,000, for a total product of 3,577. Okay, seeing a couple of answers, both of them 3,577. So those people stick them in the chat. Kudos to you, because your answer matches the correct answer. All right, everybody. Thank you for tuning in. Exit Ticket is on Google Classroom, and in about 5 minutes or so, office hours will be open if you have more questions about area model, you want some extra practice problems, I'm happy to give them to you. Or if you just have any questions or concerns about this topic. All right, remember, as I go back to the full cam here, remember our steps. First step, put your factors in expanded form. That's going to tell you how many partial products you're going to end up having. Okay? Then multiply to get those partial products, and then add your partial products together to get your total. All right? Happy math. Good luck. I will see you soon.